Greetings, Earthlings. I am Christopher Horitzner from Earthiversity, and today I'm going to introduce you to the art of Google Earth Engine. And hopefully, with a little bit of luck and a lot of hard work, you'll be able to harness remote sensing to be able to answer scientific questions about the world. So quickly, we'll go about the why. In short, today, you're going to be picking a time span of your choosing and a location of your choosing, and we're going to draw from Landsat 8's rich database and run a couple of functions to sort a collection of images called scenes over this location to give us the image over our region of interest that has the lowest cloud cover. In other words, we want the highest quality image over this time span that we choose in the given location that we're going to call our region of interest. Lastly, we're going to display the image of our chosen location using band designations and visualization parameters to better attain the images that we want. We're going to learn how to save our attained images with its associated visualization parameters, and at completion you should be able to understand the difference between radiance and reflectance, load imagery with the units of interest, make true color and false color composites, and identify land cover types based on spectral characteristics. So let's talk a little bit about the prerequisites. Remember, if you're new to JavaScript or programming in general, I'm going to link some sources at the bottom in the descriptions for you. Otherwise, the steps here are easy enough that self-contained you should be able to replicate this process with as little as introductory knowledge of JavaScript or coding in general. So without much further ado, let's get started. All right. So, the first thing we want to do is import the correct Landsat imagery into Google Earth Engine. And so to get to Google Earth Engine, you want to go to code.earthengine.google.com. Remember, if you haven't already signed up for Google Earth Engine, you will not be able to access the coders side of Google Earth Engine. So please see my first video on the subject to figure out how to sign up for Google Earth Engine. So, I'm going to go ahead and direct us to the exercise 2 files. So what we want to do here is upload Landsat 8 imagery, the correct imagery. All right, so you'll need to go over this search bar here, where it says search places and datasets, and you're going to type in exactly as I type in. USGS, Landsat 8, TOA, that means top of atmosphere, and then you're going to write reflectance. Okay? So USGS Landsat A, collection 1. So here, I'm not liking the myriad of results that I'm seeing. USGS Landsat 8 TOA. Did I spell reflectance wrong? Reflectance. Oh. This is strange. Here it is. I'm not sure why this wasn't popping up first in our search query, since it's basically exactly what I wrote. I'm going to try to figure this out. So I'm going to write ortho rectify. There we go. So the problem here is actually that there's a lot of a preponderance of data here available to download that are actually in raw files. Okay, what we want to do is actually not download the raw file for the Landsat 8 top of atmosphere reflectance. We want to download the ortho-rectified files. Okay, so go ahead and in the rosters, you can see that it comes up under rosters. These are all rosters. Click it, and before we import it, orthorectification is the process of removing the effects of image perspective, or tilt, and relief, so terrain effects, for the purpose of creating a planimetrically correct image. The resulting orthorectified image has a constant scale wherein features are represented in their true, more or less, true positions. Okay? So, FYI, orthorectified means distortions removed. So good thing. We want to use orthorectified images. You can see the revisit interval here. says 16 days. Interesting. So that means that this data type collects every 16 days. So let's import. And we're going to call this variable Landsat, like that. So one thing you should know, the Landsat 8 and 7 satellites both maintain a near-polar sun-synchronous orbit. They each make an orbit in about 99 minutes and complete over 14 orbits a day and provide complete coverage of the Earth in every 16 days, as we saw when we pulled up as such the revisit interval every 16 days. So let's do a bit of a synthesis moment. Every time you're looking at a specific scientific question, you want to keep the temporal horizon of your question in mind. See? So you want to keep the temporal horizon of your question in mind whenever you're asking an Earth-related question in Google Earth Engine. So Landsat 7 and 8 give you a complete picture of the Earth every 16 days. So if you're trying to use the Landsat images to view an event, a singular event such as a tsunami, you're not going to capture this in a 16-day collection. Rather, you will need to know if the satellite was over your location of interest at the time of the event, at the times the tsunami hit wherever you're interested in, and import the raw data scenes. First, we must import the Landsat 8 imagery. I suggest you call it Landsat, as I have in lowercase here. And also create a point geometry and call it point, and I'll show you how to do that. You're going to go down here to where the map is, and you go to add marker. Now here's where you get to pick the location of your choice. You can pick whatever you like. It doesn't have to be in the United States. I'm going to pick an area in New Mexico, right here. It looks kind of green. Somewhere I'd like to go. All right, so we're going to call that geometry point. The variable, we're going to redefine the name as point. Oops. P-O-I-N-T. I like to keep all my variable names lowercase. Now, if you wish, you can change your nomenclature to whatever you'd like, but it can get a bit confusing later on, especially when we get into longer prompts. Today's exercise is going to be relatively short. So let's get on to the coding bit. This is the fun part. All right, let's start off by defining the image of this Landsat collection. So we're going to create a variable. We're going to tell this that the variable image is equal to, and this is how we set this function, we call this function, ee dot, capital I image, and then open parentheses, Landsat, and then we're going to hit space. We don't want to close our function just yet. We're going to call a couple other functions inside of our function. First thing we want to do is filter by a date of our choosing. Okay, filter date with a capital D, open parentheses, and the date you will fill in here in this format: year, month, date. So I'm going to do 2014, and we're going to do a range of dates, dash 01 dash 01, so that is January 1st of 2014. And then we're going to say that's the start date to filter, and the end date, we're going to set it as, I'm going to set it as, whoops, 2014, December 31st. Whoops, December 31st. I apologize ahead of time for all of the typos that I will inevitably make. All right, so now that we've filtered by date, I specified that I'm going to search within the year 2014. You can specify a different year, whatever year you need to answer your scientific question. Now we're going to filter by bounds. So we're going to, whoops, that doesn't call a function because I didn't start with a period. Dot filter, capital B bounds, right? It's just like filter date, except now we're doing it by a geometry. We're going to open parentheses, and we're going to use the geometry that we defined as point. So the exact point that you chose, okay, is the point that we're going to filter by, okay? Think of it as a pin going through the Earth at that exact location. Now we're going to press enter. We're going to keep our function open. What we want to do now is sort, call the sort function. Now this is really neat, right? Thankfully, the Landsat data have a metadata property that allows you to sort the scenes in this collection, right? And the lowest cloud cover is sorted highest. And this metadata property, I'll give you a hint, is called cloud cover. It's that easy. Cloud underscore cover. Now, I will show you quickly how to easily obtain all the properties that you can call out as metadata properties whenever you're making functions or otherwise playing with your Landsat data. So if you go into this, you go down to image properties, you can see all of these you can call out and include in your functions. So here's cloud cover, what we just used. We sorted by cloud cover. You can see here in the description that it is percentage cloud cover, so 0% to 100%. And then -1, anything that's represented as -1 has not been calculated. Cloud cover land, which is percent cloud cover over land. Same thing with the -1. Date acquired, datum, ellipsoid, file date. You can see all of these and their descriptions. Just a quick tip. It's always good to play around. Next thing we want to do, we have our sort function sorting by the metadata property cloud cover. And so what you're getting is every 16 days in the year 2014, there was an image taken, a compiled image, that was then orthorectified and representing the location of interest that I chose in this point that we filtered by in northern New Mexico. Now that's quite, a number of images, and we're sorting to find the best one, the lowest cloud cover composite. So what we want to do is say, give me the first one, the first and best one, right? So the last thing we're going to do inside of our function is do a first, and then we're going to close our overall function using a semicolon, and we're done, okay? So let's go ahead and hit run. Let's see what that does. Huh, nothing, right? Let's hit run again, nothing. Okay, so you'll see when I hit run here that nothing interesting happens, nothing pops up at all, and that's because we haven't told the program to spit anything out either into our console or to add any map layers, right? We have to actually tell it what to call out. So what we're going to do here is do the print function, okay? I'm introducing you to a new function here called print. We're going to do print, and inside the single quotes, we're going to call it what we're going to call it. So I'm going to say this is a Landsat 2014 scene, and I'm going to put open colon right there. Then I'm going to comma, and I'm going to specify that this is an image, and then I'm going to finish my function. Remember, we always finish our functions with a semicolon, right? So now let's run it. All right, so we see here that in the console, an image came out. It's called Landsat /LC8 underscore L1T underscore TOA, and then this huge string of numbers. What we can do is actually drop this down and see that it's an image, right? We can see the exact ID, right? And if we wanted to see this image, we could actually go to the Landsat website and call it by the exact ID. These tags you can use to bring up the exact scenes that you want in the Landsat website, which I believe is now curated by USGS. So all of the prior Landsat missions that have either ended and finished their duration out in space collecting data, or are still ongoing, like Landsat 7 and 8, are curated now by USGS, just a fun fact. So you can drop down the bands, and that's the 0th band to the 11th band, okay? And if you go to the band designations here, you can see the same information here, but in a little bit more intuitive way. Band 1 is a 30-meter resolution band, 30 meters by 30 meters, in a raster file. The wavelength is 0.43 to 0.45 micrometers, and this looks This is used to look at coastal aerosols. You can see that bands 2, 3, and 4 are blue, green, and red. All right, so a good mnemonic I like to use for RGB, red, green, blue, is 432 in Landsat 8 designation. Red, green, blue is 432. It's a pretty good mnemonic if you ever forget what blue, green, red is in Landsat. So we've printed this image, the least cloudy day, or sorry, the least cloudy composite in the year of 2014 in this northern New Mexico region. We've printed that image into our console using the print function. Next, right, we're going to call out our visualization parameters for this image using a JavaScript dictionary, okay, simply by defining our bands, like so. We're going to call out a variable true color, true, capital color. I'm going to set this equal to, and then we're going to open brackets. I'm going to hit space. I'm going to index the next line. We're going to say bands, colon, open bracket, B4, comma, B3, comma, B2. Remember, 4, 3, 2 is what? Red, green, blue, right? 4, 3, 2, red, green, blue. Okay, so those are the bands. Let's go ahead and hit comma. Go to the next line, and we're going to set a hard minimum. I'm going to set that to 4,000 as the value, comma. I'm going to set a hard maximum, and we're going to set that to 12,000. Okay, then let's go ahead and close this function by putting a semicolon after the last open brackets. If you want to see any more about the bands defined here for Landsat 8, you can also check out this resource. It is this Landsat website, landsat.usgs.gov, and a lot of questions have been asked here. You can look at the facts, FAQs, and they provide really good information about their bands and what they're used for and the kind of remote sensing that can be done with them. So I'm going to put that down in the video description as well. All right. So we've defined visualization parameters for our image, but we haven't actually called the image to the map yet. So we haven't actually added a map layer to the map, right? So how can we do that? All right, so here is the function, map with a capital M dot add layer with a capital L, open parentheses. We're gonna use the word image in this argument to define that this is an image. Then we're going to say true color, this is the object defined above, comma, and then we're going to say true color image. That's what we're calling this map layer, and we have to end all of our functions with a semicolon. Now let's go ahead and run. Okay, you see that a black square popped up in New Mexico, all right? And that's not exactly what we wanted, but we're going to play with it, all right, so that it represents what we'd like. Observe that this image is displayed according to the visualization instructions in the true color dictionary object. Specifically, bands is basically a list of 3 bands to display as red, green, and blue, respectively. To understand where these band names come from, you can inspect the bands property of the image in the console. Right, like we showed here, drop down, go to bands. But there's more than one way to discover the appropriate minimum and maximum values we should be using. Here, I gave you a hard minimum and a hard maximum. But another way we can do that a little bit more organically is going into the layers and settings for the true color image. Go to the cogwheel here, okay, to open up the parameters. Make sure it is set to 3 bands RGB, and then it's 4, 3, 2 to represent red, green, blue, okay? Make sure your min is 4,000 and your max is 12,000. Now, the problem, why it's all displaying as black, is because here you can actually set the layer manager to automatically compute a linear stretch based on the pixels in the map display. In other words, there are a limited number of pixels where sensors actually derived data, and these are not enough to display a true image. But if you create a linear stretch between those pixels, then it will create something that's perhaps less true, but more continuous and pleasing to the eye. So let's take this and set the stretch to 98%, okay? Don't play with the opacity or the gamma for now. Let's go ahead and hit apply and import for fun. And let's close this. Now let's zoom in on our map layer. That changed drastically. It used to be a black dot. Now I can see, wow, this is interesting. There's black ridges, what looks like either running rivers or beds of what used to be running rivers. You can see clouds here. This is just northeast of Albuquerque. So this is a true color image, meaning that this is what our eyes would see in red, green, and blue. Let's make sure that this is a 98% stretch. And yeah, it is. So this can be very useful if our question of interest, if we're going back to the original question, scientific question of interest, has to do with the Earth as it is and how we see it. So can we see visibly, desertification in the northeast Albuquerque in 2014? That could be an example of how this would be useful. So we defined our true color image. Next, we're going to define our false color visualization parameters. And false color can be just as, if not more, useful than true color. It might not be intuitive to the eye, but we can derive a lot about the Earth and the Earth's surface using false color images. So let's go ahead and create a variable just as we did true color, but instead this time we're going to call it false color. False, capital C, color is equal to open brackets, and let's space and index this next line and say bands. And we're going to say colon, and we're going to open our brackets. I'm going to say B5. You'll notice that last time we used B4 here. Now we're using B5. We're also using B4 and B3. So B5, B4, and B3. We're going to set a minimum, a hard minimum like last time. We're going to set it to 4,000. We're going to set a maximum. We're going to set it to 13,000. Then we're going to make sure we end our function with a semicolon. So what is band 5? If it's not red, it's not blue, and it's not green, what is it? It turns out it is near infrared. So we do not actually see with our eyes in the near infrared wavelength range. So this, although it doesn't represent what we truly see, might actually be very helpful in determining things about the Earth's surface. This is where remote sensing basically takes our understanding beyond what our senses are capable of picking up. So if I run this, nothing's going to happen. We have to actually add this layer to the map. So we're going to use our function that we've used earlier, map.add layer image. This time it's false color, false, capital C color. And then we're going to call this false color, oops, composite. And then we're going to end our function with a semicolon. Now we can run this. So let's go ahead and look at our layers and turn off the true color image so that we can see the false color composite. All right. So let's go ahead and remember the reason it's black is because there's no linear interpolation over the pixel values. If you want a continuous image, you have to stretch it some way. And this linear stretch is a good way to do it. 98%, hit apply. All right. So this is an interesting image. We can see, even if it's hard to interpret with our eyes, differences in color here, differences in what's being represented using the bands 5, 4, and 3. So one of the useful properties of Google Earth Engine is you can go into this Inspector tab here. All right, you put your Inspector Gadget hat on, and you come out here and you can click on any point in your raster layer image. Like, let's say, let me zoom in a bit here. This white area here on this ridge, and we can look at the band properties, the exact band values at that exact point. So the true color image, you can actually see it in chart form as well, which is useful. It's a useful visualization. Let's look at B5, which is our near infrared. So B5 in this white-ish region is 0.31 or 0.32. Now let's see what it is in this slightly more red image here. Here it's 0.27, so it's gone down. Let's see what it is in this more darker red, this more saturated red. 0.21, so it's continuing to go down. What about in this very dark red here? 0.13. So there's kind of there's a bit of a trend here, right? The lighter areas tend to be higher in the near infrared band. And near infrared values in the near infrared sensor just might have a correlation with land surface temperature, right? So that's a really neat thing to do. It turns out you can actually back out what the land surface temperature is in this exact map image, right? And it is true that areas with higher values in the near infrared band sensor are areas with greater land surface temperatures. And there are ways we can actually call out this using functions in Google Earth Engine. And I promise it's actually not that hard. So the important thing here, it's not just one area of the Earth. We can do time series coverages of the Earth. It depends on what our scientific question is. And of course, remember, we have to always keep in mind the temporal horizon of our geospatial question whenever we're asking Earth-related questions in Google Earth Engine. In case we wanted to have a clearer, in this case, we wanted to have the clearest picture possible of our region of interest in the year of 2014. We accomplished that, if you remember, first by filtering using the convenient metadata property called cloud cover. Furthermore, we learned how to define visualization parameters to get an image to represent what we needed to answer for our scientific question. So that's all for this video. There's much more to come in this series coming up. So see you guys next time.